Iterators are a design pattern that allows us to traverse elements of a compound data structure, such as a Java collection, in a safe way. Consider this example where we attempt to go through a list of bills and remove those that were already paid. We attempt to do this by letting an integer I range from 0 up to n-1, the last index, and access the current entry on the list by its index. But this is error prone and probably not what we want. To see why this piece of code is problematic, consider a list of 4 bills. Let's say we have a paid one, another paid one, an unpaid one, and another paid one. And the indices of these items are, of course, 0, 1, 2, 3. Now what happens when we consider the first item, we see, oh, it's a paid bill, so we remove it, which is what happens in line 5. But calling this remove method, of course, shrinks the size of the list. So this means next time we compare the index I to the size of the list, which is our termination criterion, we would compare to a smaller size. So the question is, would we actually ever consider the last 2 items? That particular problem doesn't occur, and that is because, in fact, the remove method would re-index the list. So this means after the first removal, what we see is the index changes to 0, 1, 2. But this means that in the next round, our variable I is index 1. So this means we are now jumping over the second item in our original list and continue looking at these items from this position. Again, this is not what we want, which was to consider each bill individually and remove it from the list if it has been paid. It is, of course, possible to hotfix this example by manually resetting the variable I whenever you are removing something, but it should be clear that this is error prone and highly dependent on the behavior of the underlying collection. It would be much better to separate the traversal logic from the underlying collection, and that is exactly where iterators come in. Iterators give you a way to access the elements of an aggregate object, i.e. a collection, one by one without exposing the underlying representation. Iterators are objects, so they have attributes, methods, etc. And they're intended to be cheap and single use. They represent one iteration across the collection. Once you're done with the iteration, the iterator gets discarded completely forever. The iterator provides safe read and write access to the underlying collection. And it's often created by the collection itself. So you can call the iterator method on any collection, and that would provide you with an iterator without having to know how the iterator itself works. Now let's look at this example one more time and iterate over our collection of bills using an iterator. The way you do that is you get an iterator from the collection itself, which is what happens in line 2 here. So what this does is it declares and initializes a variable called iter, which is of type iterator of bill. So it's again a parameterized type. And I get that simply from the iterator method of the collection itself. Iterator is an interface that declares methods has next, next, and remove. So we can say while the iterator has next elements, get one and inspect it, etc. And then crucially, we remove it from the list by calling the remove method on the iterator. And now it's the iterator's responsibility to remove it from the underlying list, resolving any possible problems. So what we see here is that iterator for a given type is a parameterized interface. You must specify the type of object that is being iterated over. And that is exactly the type of object stored in the collection, which is why often you would get the iterator from the collection itself. Iterators provide this safe remove method, and what it does, it takes no parameters and it removes the last element returned by the next method of the same iterator. Notice that this remove method is on the iterator and not on the collection. It's a completely different method that just happens to have the same name. Finally, a neat shortcut. If you don't actually need to access the iterator, if you don't need to write to the collection, you can use this alternative for syntax. In this case, for bill b colon builds, that allows you to iterate over all elements in this collection builds and calls the current one b. And that's completely equivalent to getting an iterator, iterating over it using a while loop, and call the current element b. The nice thing is you can use the exact same syntax on arrays. So if builds was an array of builds, then you can also use the same syntax to iterate over them.